Today we're going to look at slope and rate of change. Our objective is to be able to find the slope from 2 points, to be able to determine if two lines are parallel, perpendicular, or neither, to find the rate of change, and to be able to write a linear equation using a given rate of change. So what does slope describe? Slope is actually the steepness of a line. So what that means is basically how slanted it is. Is it going up and down pretty steeply? Is it completely horizontal? Is it straight up and down? It'll tell us if it's a positive slope, if it's a negative slope. So what we're going to use today is the slope formula. So we have m is the letter we use, equals, and it's really the change in y over the change in x, and we use that by delta y over delta x. And we have a formula for our 2 points, y1 minus y2, divided by x1 minus x2. And some books and teachers put the 2's before the 1's, but that doesn't matter, the order, as long as either both 1's come first or both 2's come first. So let's just do a little example. Let's pretend we have a point 2 comma negative 3, and let's say negative 1 comma 5. If we have that, how would we find the slope? Well, I know it's the change in y, so I'm going to take y1 and subtract y2, and I'm going to take x1 and I'm going to subtract x2. So be careful with the double negative. So in the numerator I get negative 8, in the denominator 2 negatives make a positive 3, so I would get a slope of negative 8/3, and that's all you need to do. So how can we use slope to help us tell whether lines are parallel, perpendicular, or neither? And one thing to know is if we have parallel lines, they're going to have the same slope, and that's usually what students remember, that's the same slope. But you have to remember they must have different y-intercepts. If they have the same slope but the same y-intercept, in fact they're actually the same exact line, so they can't be parallel, because if I have two lines drawn on top of each other, they would intersect, so they would not be parallel. If I want to tell if two lines are perpendicular, I can check to see if they have opposite reciprocal slopes. And opposite reciprocal means if one, for example, is 2/3, the opposite would mean if this is positive, the other one should be negative, and reciprocal, we're going to flip the fraction. Okay? It doesn't matter what happens with the y-intercept, all we care about is the opposite reciprocal slope. And if neither of these are true, that must mean that they have different slopes, but they cannot be opposite reciprocal, and that's the difference here. So let's look at a couple examples. We have 3x minus 4y equals 12 and 8y equals 6x minus 24. So how can we tell if they're parallel, perpendicular, or neither? Well, the easiest way to do that is to solve for y. So I'm going to take the first equation, our 3x minus 4y equals 12. I'm going to first subtract the 3x over, and then divide by negative 4. And if I divide by a negative 4, I'm going to get a positive 3/4 x, and divide by a negative 4, I'm going to get negative 3. So that's my first equation. If I do the same thing for my second equation, it's almost already done for me. It's going to write 8y equals 6x minus 24. If I divide everything by 8, I'm going to get 6 over 8, which if I reduce by 2, I'm going to get 3/4 x. And negative 24 divided by 8 is a negative 3. So now if I compare these two lines, I notice that they have the same exact slope. However, I cannot forget to look at my y-intercept. Because they have the exact same y-intercept, these two lines are the exact same. So actually they're not parallel and they're not perpendicular. They're actually the exact same, so I'm going to say these are neither. If I look at example number 2, I have x plus 7y equals 21. Again, what I'm going to do is put it in the slope-intercept form because that's the easiest. I'm going to subtract x from both sides. And then I'm going to divide both sides by 7, which gives me, remember this is a negative 1, negative 1/7 x plus 3. And if I do the same for my second equation, my 35x minus 5y equals 50. Okay. So what I'm going to do here is subtract the 35x, my plus 50, and then divide everything by a negative 5. So if I divide negative 35 by a negative 5, I get a positive 7x, and then I'm going to be left with a negative 10, 50 divided by negative 5. So now I want to compare first the slopes. I have a negative 1/7 and a positive 7/1. So these are, in fact, opposite reciprocals. I don't care about the y-intercept, but as soon as they're opposite reciprocals, what I know is these are perpendicular. And if you remember, our symbol for perpendicular from geometry is an upside down T. So the next thing we're going to talk about is rate of change. A rate of change is a rate that describes how one quantity changes in relation to another quantity. And you've dealt with these before, but you might not have used the term rate of change. And the key thing is to make sure our units are the same. And you're going to see that in our next example. So our first thing says, at 3 weeks old, a corn plant is 4 inches tall, and at 15 weeks, it is 3 feet 10 inches. Find the rate of change. So what they want to know is we're doing a comparison of units. So if you notice, we have time, 3 weeks and 15 weeks, and we have height, 4 inches and 3 feet 10 inches. Time is always our x value, our independent variable. So time is always on the x. So really, all rate of changes is slope. So again, our slope is our change of y over our change of x. And again, x is, if we have time in the problem, it's always our x. So if we look at our time, I'm going to do that first. I have 3 weeks and 15 weeks. Those are in the same units because they're both weeks. So I'm going to do 3 minus 15. Now at 3 weeks, we had a 4-inch tall corn plant. But at 15 weeks, we have a 3-foot 10-inch plant. Now, these are not in the same units because this is in inches, this is in feet and inches. So what I want to do is convert this to inches, and that's what I'm going to choose to do. So 3 feet, okay, each foot is 12 inches. 3 times 12 is 36. 36 plus 10 is 46 inches. So I'm going to do 4 minus 46. 3 weeks, 4 inches. 15 weeks, 46 inches. So if I subtract this, I'm going to get a negative 42 in the numerator and a negative 12 in the denominator. Now whenever you're doing rate of change, it's not like our normal slope. If this was slope, I know 2 negatives make a positive, and then I'd reduce this fraction. But when we deal with rate of change, we want to actually get it over 1. So we actually want to divide this out completely. And if I take negative 42 divided by negative 12, type that in my calculator, I'm going to get 3.5. And what that tells me, if I have 3.5, and again, remember my numerator is inches, okay, over 1 week. Whenever you do rate of change, again, you always want the denominator to be a 1. This will sometimes be written as 3.5 inches per week. Okay, we like the denominator to be just the unit. So how can we now use this to write a linear equation? So it says write a linear equation h that models the height, and that's why we use h, of corn for the 12-week period. Because again, this was 12 weeks, from 3 weeks to 15 weeks. Now this is the important thing. Let t equals 0 represent week 3, and that's actually very helpful. So let's just think about what this would look graphically, since we're going to write a linear equation, so our graph must be a line. If I let t equal 0, that's my time. Okay, so time is down here. So time 0 really represents 3 weeks. And again, this is going to be my height, my y value. Well, I know at 3 weeks, so I'm going to put that at time 0. I was at 4 inches. Okay, and then I know if I go down to 15 weeks, okay, which is my 12-week period, okay, I'd go all the way up, okay, because again, really this is week 3 and this is week 15. I was all the way up at 46 inches. So really what they're asking for is what would be the equation of this line. And we're going to talk about this a little bit more in a couple sections, but to write the equation line we need to know 2 things. We need to know the slope of that line, our rise over our run, which is the exact same as rate of change, and I need to have the y-intercept. Well, because they told me t equals 0 represents week 3, and I know the value at week 3, which is really nice, I know my y-intercept is at 0, 4. So if you remember how to write the equation line, y equals mx plus b in slope-intercept form, my answer would just be y equals, my slope is my rate of change, and that's why we use that so much, it's important, and my y-intercept, since we know we're starting at time 0, which is week 3, is 4 inches. And that's all you have to do to write an equation. The reason this is important is because now I can make predictions in the future. I could say, all right, what would possibly be the height at, let's say, 20 weeks? Okay, and then I can substitute different values in to kind of go from there. But we'll talk a little bit more about what we'd actually substitute in for that, because if you notice, week 3 is actually a 0 for my time, and then if I wanted week 20, that would actually be at 17. So we're going to get into this a little bit more as we get into the rest of the chapter. So hopefully feel a little bit better about slope and rate of change. And you're able to find the slope from 2 points, determine if 2 lines are parallel, perpendicular, neither, find the rate of change, and to be able to write a linear equation using a given rate of change.